In section 5.3, we will talk about factoring special products. The first special product is called a difference of two squares. So let's break this down. A difference means subtraction, so we have to have the operation of subtraction. And what are we subtracting? We're subtracting two perfect squares. So it's subtraction of two squares. Now when that happens, when you have a difference of squares, we don't have to do the whole x factor method. We can just do a plus b times a minus b. For example, we have 25x squared minus 49. The main thing we have to realize is that 25x squared and 49 are both perfect squares. Now, why are they both perfect squares? So 25x squared, this can be written as 5x to the second power, and 49 can be written as 7 to the second power. So now we have the format a squared minus b squared, where a is equal to 5x and b is equal to 7. So if we factor this, this is going to be a plus b, which is 5x plus 7, times a minus b, which is 5x minus 7. And notice that 5x times 5x is 25x squared, 7 times negative 7 is negative 49, and the middle term just goes away because we have a negative 35 and a positive 35. That's why the middle term goes away. Next up, we have 64x squared minus 81. So once again, this is going to be 8x to the second power. It's a perfect square. 81 is 9 to the second power. So 8x is your a value, 9 is your b value. So this is going to be 8x plus 9 times 8x minus 9. So with a difference of squares, you think about which term multiplies to 64x squared, that's 8x and 8x. Which term multiplies to negative 81, that's positive 9, negative 9. And that's all there is to it. The next one, we have x squared minus 16 is equal to 0. If we factor this, this is x plus 4 times x minus 4 equal to 0, a difference of squares. The zero product property states that if two terms multiply to 0, then either a has to be 0, or b has to be 0, or they both have to be 0. So in this case, if we set x plus 4 equal to 0, or x minus 4 equal to 0, and solve this, then here we get x equal to negative 4, and here we get x equal to positive 4. Next up, we have 49x squared minus 36. So the 49x squared, we can split this up as 7x times 7x. The negative 36, we can split this up as positive 6 and negative 6, and that equals to 0. Now, according to the zero product property, if two terms multiply to 0, then either 7x plus 6 has to be 0, or 7x minus 6 has to be 0. So here, I subtract 6 from both sides. I get 7x is equal to negative 6. I divide both sides by 7, and one answer is x equal to negative 6 over 7. For the other answer, I add 6 to both sides. The opposite of subtracting is adding, so I get 7x equal to 6. Divide both sides by 7, and I get x equals to positive 6 over 7, which are my two answers. Now notice that a squared plus b squared cannot be factored. So if you have a sum of squares, this is not factorable. For example, if I say that x squared plus 4 is equal to x plus 2 times x plus 2, what's wrong with that? This is incorrect. Okay, why is that incorrect? What's wrong with that? Well, let's see what happens if I multiply x plus 2 times x plus 2. I get x times x, which is x squared, and then I get a positive 2x and another positive 2x, and then I get a positive 4. So this gives me x squared plus 4x plus 4, which is not the same thing as x squared plus 4. That's not the same thing as what I said my term equals to. So because this is not equal to x squared plus 4, x squared plus 4 is not factorable. So if you have a squared plus b squared, this is not factorable. Something to keep in mind. All right, now, what if we have a plus b squared? Notice that that's different than a squared plus b squared. So here, the a plus b these are in parentheses. So what happens is we get a times a, which is a squared, and then you get a positive ab and another ab. This is going to be a 2ab, and then you have b times b, which is b squared. So when the first and last term are both perfect squares, and the middle term is 2 times the product of a and b, then the trinomial can be written as a plus b squared. That sounds kind of confusing, so let's take a look at an example. First, we have to know how to recognize it. First, we have to know how to recognize it. So this is used when we have this format, when you have a squared plus 2ab plus b squared. So the first term and the last term, they both have to be perfect square. So that's how we know that this scenario might be happening. So in this case, 25x squared, that's a perfect square, and 4, that is also a perfect square. So 25x squared, this is the same thing as 5x to the second power, and 4, this is the same thing as 2 to the second power. Now, the middle term is 2 times 5x times 2. So 5x times 2 is 10x, and 2 times 10x is 20x. So whenever the middle term is double the product of 5x and 2, which it is in this case, then we can use this formula that 25x squared plus 20x plus 4, so a squared plus 2ab plus b squared equals to a plus b to the second power. In our case, a is 5x, this is your a value, b is 2, this is your b value. So according to that formula, if a is 5x and b is 2, then this will be 5x plus 2 to the second power. And we can check to see if this is correct. Remember, anything to the second power, you have to write that out twice. So you have to write that out as 5x plus 2 times 5x plus 2. Now if I FOIL this, I get a 25x squared, and then I get a positive 10x and a positive 10x. And then I get 2 times 2, which is 4. If you add the like terms, this gives you 25x squared plus 20x plus 4. And that's exactly what we started off with, so this is going to be correct. Let's take a look at the next one. We have 16x squared, so that's a perfect square. I'm going to write that as 4x to the second power. 49 is a perfect square. I'm going to write that as 7 to the second power. Now notice that if you take 2 times a times b, so if you multiply 4x times 7, which is 28x, and you take 2 times 28x, that gives you a 56x. That's exactly what our middle term is. So it fits that pattern where the middle term is 2 times ab. In that case, we can follow our formula, which is going to be a, but in this case, because of 56 is negative, it'll be 4x minus 7 squared. And then lastly, we have 4x squared minus 36x plus 81. So once again, let's recognize that 4x squared, this is 2x to the second power. 81 is 9 to the second power. And 36 is, so 2x times 9 is 18x. And then 18x times 2 is 36x. So the middle term fits that 2ab pattern. So then if I factor this, this is going to be 2x. And not plus 9 because the middle term is negative, so it'll be 2x minus 9 squared, and that's equal to 0. So what does this mean? Anything squared, it means you have 2x minus 9 times 2x minus 9, and that equals to 0. Now, according to the zero product property, if I solve this, then I said 2x minus 9 equal to 0. I add 9 divided by 2, and I get x is equal to 9/2. The second one is the exact same thing, so even if I said 2x minus 9 equal to 0, that second one, then I'm still going to get x equals to 9 over 2, so this is our only answer. X equals to 9/2.